Welcome back to the Home Lab, and I've got an interesting little electronics build to show you today. What I've built is a digital dice, or what I call a Digidice. So, as ever with me, there's a backstory to everything, so bear with me, just a quick little story before we begin about how this project came about. So, many years ago, I think it was over 30 years ago, I was teaching at, I think it was Cheltenham College, or it could have been Bedford School, I can't remember which, and they organised a day out to Texas Instruments, which was extremely exciting because when we got there, what they showed us was a little tiny circuit board that we were going to build with one chip on it, and a switch and a little PP3 battery, and you pressed the switch and it scrolled through numbers from 1 to 6, and as soon as you let go of the switch it showed a number. It was a digital dice. And the way this worked was really interesting. They took us into a computer suite. Now I think you realise just how interesting that must have been back in the day when we didn't really have PCs. And they had computer-aided design, and on the screen were a whole series of logic gates, and, nor, not, etc. And what you could do is drag these together to make the circuit you wanted. So the engineers showed us how to make a circuit that would count up to 6 and then stop when you let go of a switch. So we added 1 or 2 gates, not all of them. And then they put that program into a machine which burnt a chip. Now, it wasn't EEPROM, if you know about that. It was actually a chip with loads of sort of loose gates on it. And what you could do is electronically connect those gates together. You could kind of burn the diagram you'd done on the screen. So we plugged in our blank chip, pressed go, and it encoded inside the chip all the gates that we'd drawn on the computer screen. And then we could put it into a ready-made circuit board. There was a little dual line socket on that, plug in our PP3, and we all went home with this tiny little circuit that was a digital dice. I have no idea what I've done with it, but I was fascinated by that, even as a teacher. And about 30 years later, I thought it was time to build one for Barry. So over the Christmas period last year, I had a little bit of time on my hands, and I thought, well, can I draw a circuit that will do the same thing as that TIC-PAL, so Texas Instruments Programmable Array Logic chip that I'd seen so many years ago. So I thought all I've got to do is get a few chips together, one that will count 1, 2, 3, 4, 5, 6, and then the ability to display it on a 7-segment display. And I got some of these rather nice huge 7-segment displays. So got to drawing the circuit and put it all together and ended up with this, what I think is a rather fine looking thing. So let's have a look at how it actually works. So as ever with my projects, the first thing to do was to build it on a bit of breadboard and to make each piece as I went along and test each separate piece. So I got out a breadboard strip and put the 555 timer on it, then a 4017, which was the chip that would switch on a single pin. Then the little diode array that would convert the output from a single pin to a binary number, and then the 4511 chip, I'm looking behind me because I forget these numbers, that would then convert that binary input into an output that would drive a 7-segment display. I also put some Darlington drivers in. These are just chips that would increase the current a little bit to make sure that the LEDs and the 7-segment display lit up correctly. So once I got it all working on a piece of breadboard, it was time to actually solder together a circuit. And it was here that I had a bit of an interesting thought about how I wanted it to look. So I bought a lot of tiny little circuit boards for projects, and I didn't really have a use for them. You know how it is. You see something interesting on the internet, you think, oh, I'll buy one of those. And then you think, did I have a use for that? Well, I had them in my box of components, and I thought, I'll tell you what I'll do. I'll build each bit of the circuit on one of these boards. So I'll have a separate one for the 555 timer, a separate one for the Darlington arrays, a separate one for the LEDs. And then I'll wire them together with single core wire. And what I ended up with in the end was a working circuit, but a spaghetti of wires, etc. And I thought, crumbs, how am I going to sort of put all this together? Normally I build circuits on sort of these kind of boards, you know, a single board, but I wanted to do something different. And that evening, I just chucked it onto my computer printer, the top of the printer, and left it there for a while. And it was only when I looked at it, I thought, that looks amazing. It looks like a sort of exploded electrical circuit. I wonder if I could just leave it like that, make it a little bit more rigid so it doesn't fall apart, and put a box around it. So the next few days, I gave some thought to how I could actually mount it in a box. So the next job was a bit trickier than I thought, but I wanted to give it a go. I've never actually properly built a box out of Perspex that is bolted together. So not screwed together and not glued together, but bolted together. So I got some Perspex sheet and got it cut to the right sizes, and then spent a couple of evenings drilling holes in all the right and all the wrong places to make a box for this thing. So I was quite pleased with that. I've actually screwed the base on so you can sort of get it open and replace the battery at some stage. But I was really quite pleased with this. Yes, it's got a few mistakes. One or two people have commented it looks a little bit like the computer device that used to be in Blake 7. That wasn't intentional, but it's sort of come out to look a bit like that. And then I just mounted the circuit boards inside it, retaining their sort of crazy, exploded, thrown about view. And to be honest with you, I've been rather pleased with how that came out. I must say that when you build any project with Perspex or acrylic sheet, the most exciting bit is when you get to peel that safety film off it and you see what you've made, and you've got to be really brave to leave that until the very last minute. Otherwise you're going to scratch it a lot when you're actually drilling holes and making changes with things that you'd forgotten to include earlier on. So I really look forward to that bit, and once it was all peeled off, I thought, I'm quite pleased with that actually. I think for once I've done a really good job. Okay, so let's have a quick look at the circuit now, and it doesn't matter too much if you don't follow it, you'll get the general idea. So 9-volt battery on this side, then the power switch to switch it on, and here's our faithful 555 timer with its associated components to set up the rate that it ticks at. So I've picked some components that will make it go on, off, on, off, on, off, slightly faster than the eye can see. Here's the output of the 555, so it'll be pulses going high, low, high, low, high, low. And it goes into the 4017 chip, and this is the one that every time it gets a pulse will switch on first this pin, then that one, then that one, then that one, etc. And it works its way around the pins, and when it reaches the 7th pin I set that to the reset so it goes back again. There's a pull-up resistor here, which means that the input is always high, in other words frozen, held, unless we switch on the 555 timer, and so the pulses will then cause this to keep counting. As soon as you let go of that button, it will hold the number that it was on. So here are the pins for the output of the 4017, and it's very confusing because the pin numbers on the chips happen to be 3, then 2, then 4, then 7. I've no idea why they go in that order. Normally with digital circuits we start with a 0, so this 0 one will come on first, then this one, then that one, then that one, then that one, then that one, which is why it counts from 0, 1, 2, 3, 4, 5. So that's our 1, 2, 3, 4, 5, 6 for our dice, and then the 7th event will reset the chip. So the next thing is to turn those individual outputs to a binary number that can then be decoded in the 4511 to drive the 7-segment display. So now for the clever bit, this diode array, which is really rather smart, and it takes a while to get your head around it. So the inputs to the 4511 are quite simple really. There's 4 inputs. Least significant bit, most significant bit, and we need to count up to 6, so 7 in binary is 1, 1, 1, so we definitely don't need the 4th bit here. So what happens is when this pin turns on, we want that to be a 1, so through this diode and into there, and this will then decode that binary 1 and put it on the 7-segment display. What happens when we want 2? Well, this pin comes on and goes through this diode and only to there, and that decodes as 2. 3 gets a bit more complicated because 3 in binary is 1, 1. So when this pin comes on, we need to feed a 1 into here, and we need to feed a 1 into here. So you get the idea that a single pin has a series of diodes that feed the right inputs to the CD4511. So basically it's taking a single pin and feeding it into a number of pins on this, depending on what binary number it is. Now I'm probably going to get this wrong, but let's try quickly. So 5 in, 6 in binary is going to be 110. Knew I'd get that wrong. So this is the pin that switches on when it's 6. So it's got to be 1, 1, and all the rest are going to be 0. So what happens? It comes out of here and goes into this one. Yep, that's the 1, the most significant bit. Comes out of this one and goes into there. Yep, that's another 1. And nothing up to here, so it'll be 0, 1, 1. So that will then turn into the number 6 on the 7-segment display. So it took me a while to get my head around the diode array, but it works really rather nicely. So finally, what's not shown on the circuit here, but it's really rather easy, is this 7-segment display is a little blue one that's inside the box at the back, just to check that it's working. And paralleled with that is a Darlington driver that then feeds the big one on the front. And the same here, I come off each one of these individual pins on the 4017 and go to another Darlington driver and directly to the 6 LEDs that are for the coloured dice. The only thing you have to watch there is it common cathode or is it common anode? So you need the right kind of Darlington driver. But I like using them. They're really useful for just getting a little bit more current to flow to devices that are driven from low current and low output binary chips. So of course this was built for me, but it's really built for Barry. But whenever I make something that I really like, I kind of hold on to it myself and don't let him touch it too much. But of course, at all stages of the project, Barry wanted to join in, and he was keen to test things and practice his counting and things like that. So we're quite looking forward as a family to playing some board games and bringing out the Digidice to play with.
6, 1.
So I do hope you enjoyed that video and you could follow the way this is built. Maybe you want to have a go at building one yourself. They're really quite fun. Anyway, I'll be doing another video soon and I look forward to seeing you then.